Good afternoon. Good afternoon, everyone. I'll be starting the session shortly. We'll wait for a couple of minutes to let others join and then we'll start. Is it fine?
Yes, ma'am.
Okay, thank you, sir. And meanwhile, please let me know if you can see my screen. Is it visible?
Yes, ma'am.
Okay, thank you.
Visible, ma'am.
Thank you.
Hello, ma'am.
Hello? Yes.
Ma'am, I have a doubt in multiple
Yes.
regression.
Yes.
Ma'am, actually, for one problem, we are taking more than 15 or 30 minutes to solve. So, is there any easiest method to solve an answer?
Uh, See, there are softwares and calculators you can use, and I mean, I don't know whether you're allowed to use it for.
Like for finding beta cap, we are taking more than 15 minutes
Yeah, yeah,
for the
I
calculation.
understand. See, you can use softwares. You can use R or Python or some Excel softwares to calculate the inverses quickly, like for calculation purpose. And I think you will be able to. Is there any time limit for you to complete the assignments?
Not assignment, ma'am. For examination, if they ask an exam, we have only 3 hours. So for
Okay,
all the questions, only multiple linear regression is, I think, until now it's lengthy.
yeah.
So that's why I asked.
See, for the exams, I am not very sure, but I think like when we were giving exams, we had to do it by hand only. But the problems were not that difficult. It would just extend to, 3, 4 variables so that everything can be done quickly.
So is it handwritten, ma'am, exam?
So, this NPTEL exam, this one is like you are submitting the assignments. I am not sure about the exam. I'll let you know once I'm sure.
Okay, ma'am.
Okay. Mm. Okay, so it's already 4:10. I think I'll start now. Did you all follow the lectures of this week?
Yes, ma'am.
Okay, okay, fine. So I'll start now. I'm Shreya and I'll be the TA for this course. So I'll just start with what we have learned. I'll just recap and then we'll move on to solving some problems based on week 5 lectures. So in week 5 lectures and week 4 lectures, we had learned that if there is a multiple linear regression with multiple regressors, how are we choosing them? So we are essentially learning variable selection techniques. So there were two major classes of variable selection. Anybody remembers?
Yes, ma'am.
Yes, say. Okay, so one was, fitting all possible regressions and calculating some metrics, and the second one was sequential selection, selecting one by one or eliminating one by one or a mixture of both. So for this one, for all possible regressions, we had looked into four metrics. So those were, do you remember what it were? Okay, so I'll tell. It was the maximum value of r squared, which is the coefficient of determination, or it was the adjusted r square. Whichever model had a larger adjusted r square, we took that as our best model, or the one with minimum ms residuals, or with a or regression with a mallow CP close to P, where P is my number of parameters. So this week we have learned forward selection, backward elimination, and stepwise regression. So I'll be doing sums on these concepts today so that it is more clear today. So, any doubts from the lectures?
Ma'am, there is a little confused in backward elimination and stepwise regression. Not backward, sorry, ma'am. Forward
Forward
selection
and
and stepwise.
stepwise. Okay. So, see, forward selection, we are selecting most significant variables one at a time, and then we are not going back and checking whether whatever we have included, they are retaining significance or not. But in stepwise regression, what we are doing, we are including variables and then going back and checking that after inclusion, all my previous whatever I've included in my model, is it still remaining significant or not? This is the basic difference between forward and stepwise regression. So, any specific doubt?
No, ma'am. Like, I would like, can you give us an example?
Like, for example, let's say you have five variables. Okay, so when we are doing forward selection, what we are doing, out of the five, which is the most important, or in terms of significance, I'll say, which the one which is most significant, I am taking that, including it in my model. Then out of the rest, I am checking. Let's say I have x1, x2, x3, x4. So out of these, let's say x3 is extremely important. It's most significant with highest f value. Okay. So now we are selecting that into model. So we are keeping x3. Now we have to choose from x1, x2, x3 and x4, let's say. So then the next best significant model, variable, let's say that is x3. So then what you are doing, x3 was, let's suppose x3 then x4. So x3 was already there, and we are additionally passing, yeah. So as I was explaining, let's say here we have 5 variables, x1, x2, x3, x4 and x5. So first step, we are selecting x3 into our model. So y is being explained by x3. Now next what we are doing in step 2, we are selecting out of these remaining 4 which is the most significant, given x3 is already included in our model. So let's say here we are including x5. So this is x3, x5. Then in step 3, what we are doing, we are taking the next best. We are again fitting these 3, given that x3 and x5 is already there, and uh, whichever variable turns out to be the most significant, I am taking that into the model. See, x1, x3, x5, let's say x4, this one. So if we go on like this until we can no more include any other variables, so after these 3, let's say x1 and x2, they are not becoming significant, they are having f value smaller than the threshold, so we are not including, we are stopping it here. So this one was a forward selection method. What we are not doing here is that once we have included x3, it may so happen that when we are including x5, x3 is no longer remaining significant. So in stepwise, what we are doing, we are checking at each step that after inclusion of after including x5, is x3 still significant? This question we are asking repeatedly. If this one, after inclusion of this, when x3 is there and again x5 I am selecting, then x3 is not having any significance, then we are kind of removing this one. So this is the basic difference between stepwise and forward. In forward, we keep on adding variables until and unless we see that there are no more variables present which can be added. But in stepwise, what we are doing essentially is we are adding variables and then we are checking that after addition, are all these variables necessary to keep in the model? If it is not, then we are removing. So we are adding and removing simultaneously.
So we are comparing those variables each other.
In a way we are comparing, we are seeing that if uh, after inclusion of one more variable, some other variable is losing its significance, then we are just removing it.
Okay.
But we are doing it in each and every step. In each step we are adding variables and then we are going back and checking the significance of the previously added variables.
Okay, ma'am.
It's a kind of a mixture of forward and backward thing. We are adding and removing until and unless we reach a standpoint where all my variables are significant. Because here if we keep on adding, it may so happen that these 3 in the final model, these 2 are significant. When we are calculating the partial f statistics, this is losing its significance, but it's there in the model. I want to keep my model as simple as possible, so less variables explaining maximum variation in y. That is the need to eliminate uh, which are not significant, those are kind of unnecessary variables. Okay, is it clear?
Yes, ma'am.
Okay, thank you. So, I'll start with today's problems. So, this is very similar to the problem that we discussed last week. So, again, I have given the house example. Let's say the price of a house, it depends on its age, its floor area, the locality, and the distance from the nearest hospital. And with all these variables, all possible regressions were fit. It would be how many variables? 1, 2, 3, 4. So 2 to the power 4 models were fit. These were the 2 to the power 4 models, and these variables are my regressors in the model. And for each of these models, the SS residual was calculated and it has been given in the table. Now, I have been asked to calculate this partial F statistic F1 given 2, 3, 4. What would be the value of this thing? So if you remember the extra sum of squares techniques, firstly we'll see what it means. So this one F1, 2, 3, 4. This one, it means what? What are we supposed to get? So we will consider our model as, see, beta naught is already included, beta 1 x1, beta 2 x2 plus beta 3 x3 plus beta 4 x4. So in this case, our null hypothesis would be 1, to test the significance of x1 given that 2, 3 and 4 are already in the model. So we are interested in finding out the significance of this thing. So our h naught would be beta 1 equal to 0 versus h1 is beta 1 not equal to 0. This is the hypothesis that I am going to test, and the F statistic that will come from this hypothesis will be my F1 given 2, 3, 4. Okay. Now, if you remember the extra sum of squares technique, then this test statistic was given by sum of squares due to regression from the full model minus sum of squares due to regression from the restricted model divided by the number of restrictions by the mean square residuals from the full model. Okay, I hope you remember this.
Yes, ma'am.
Okay, so now we have this will be our full model. This is our test statistic to get F1, 2, 3 and 4. Now, just give me a minute. Okay, so just a second. Okay, 1 second, my pen is not working. So this regression, as you remember from the ANOVA table, this can be written as sum of squares due to total sum of squares minus SS residuals from the full model minus SS total minus SS residual from the restricted model by number of restrictions by MS residual from the full model. So here in this case, what will be my R? Anybody?
Ma'am, is it x2?
Which one? No, this
x2?
R is the degrees of freedom. So,
Oh, okay, ma'am.
so what will be the, I mean, how R corresponds to mainly the number of restrictions. So here we have only one restrictions, that is beta 1 equal to 0 under H naught. So here our R will be 1. So if we this thing, our F statistic would be sum of squares due to residuals from the restricted model minus sum of squares due to residuals from the full model by MS residuals of the full model, and this R, since it's 1, we can write it like this. So we were taking this hypothesis, beta 1 not equal to 0. So this is my restriction. Here we have 1 restrictions. So the sum of squares due to residuals from the restricted model would be, initially it was beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. 4 variables we had. So under the restricted model, this one is 0. So the restricted model then becomes y equal to beta naught plus beta 2 x2 plus beta 3 x3 plus beta 4 x4, a model with x2, x3 and x4. So the sum of squares due to residuals from the restricted model would be sum of squares due to residuals with the model containing x2, x3 and x4, and the full model will be this one. When beta 1 is not equal to 0, then this is the full model. So this will be sum of squares due to residuals when all 4 variables are present. By mean square residual will be sum of squares due to residuals when all 4 variables are present, divided by the degrees of freedom of this full model. So here we have, let's say, n observations, and the number of unknown parameters here are 1, 2, 3, 4 and 5. So when we are estimating the betas from this model, we would have 5 normal equations. Is it fine? So the degrees of freedom of error of this full model would be n minus 5. Is this clear?
Yes, ma'am.
Yes. So once we have landed up here, we just need to calculate the formula. So I'll just do it freshly again. So here we have been asked to find out F1 given 2, 3, 4. So this will be SS residuals due to when a model has x2, x3, x4 minus SS residual when all 4 are fit by so here from the table if we see then what is SS residuals due to x2, x3 and x4? This value, okay, 1.145, and with the full model it is this value 0.274. So just substituting these values we will have here 1.145 minus 0.274 divided by 0.274 by here n was 30 because we had obtained these regressions from 30 houses. It's written 30 houses. So n would be 30. So degrees of freedom of error would be n minus 5, that is 25. So if we go ahead and calculate this, this will come to something close to 79.47 if I'm not very incorrect. I'll just check it. Minus 0.274 divided by 0.274 divided by 25, it's 79.47. This is the answer to the partial test of F1. We are testing the significance of x1 given that x2, x3, x4 are already included in the model. Is this clear? Any doubt?
Ma'am,
Yes.
ma'am, basically the equation will be like SS regression full model minus SS regression of restricted model, right?
Yes. Yes.
But why like SS residual restricted model is coming first?
Because see, I'll tell you. Do you remember this one SS total equal can be split into SS regression plus
Yes, ma'am.
SS residuals? So if you remember this, then this SS regression can be written as SS total minus SS residuals.
Yes, ma'am.
SS total equal to SS regression plus SS residuals. Okay. So SS regression I am writing it as SS total minus SS residuals from the full model, and again this one I will write SS total minus SS residual from the restricted model. So this SST and this SST plus SST minus SST will cancel out. This minus and minus will become plus. It comes in front, SS residuals due to the restricted model and minus SS residual of the full model.
Okay, ma'am.
Okay, you understood? Basically you just have to deduce this from this equation because total sum of squares can be split into two components. One component which is due to the regression model that I am fitting, and one component is the error component which is estimated by the residuals. Okay, can we move on?
Yes, ma'am.
Okay, so similarly, if we are asked to find out F2 given 134, so F2 given 134 would be SS residuals due to the restricted model where x2 is 0, I mean x1, x3 and x4, minus SS residuals due to x1, x2, x3 and x4 by MS residuals due to x1, x2, x3 and x4. You understood, no, why it is coming?
Yes, ma'am.
Okay. So then we just need to substitute. x1, x3, x4 would be this one, and the full one is this one. And just remember, when we are doing this thing, the original model, this is the full model, sorry, and our restriction is, okay, then MS residuals due to full model will be n, will have a DF of n minus 1, 2, 3, 4, 5. Number of unknowns equal to number of normal equations equal to n, and the degrees of freedom will be n minus number of unknown parameters. So just substitute 0.521 minus 0.274 by 0.274 by, here we would have 25 because you remember n was 30. So this one would come to something around 22.536. I'll just check once more. 0.521 minus 0.274 divided by 0.274 divided by 25. Yes, 22.53. This is the answer. Okay, so we'll proceed further. Now here we have been asked to find the regressor variable that will be eliminated at the first step of backward elimination. So what happens during backward elimination? First, we fit the entire model. So in step 1, what do? We check for significance of each regressors. So we will have to find out beta 1 given 2, 3, 4 are in the model, f2 given 1, 3, 4 is in the model, that will test the significance of beta 2. Similarly, f3 given 1, 2, 4 and f4 given 1, 2, 3. So from each of these variables we'll see whichever is the smallest value and which is less than the f of, which will turn out to be insignificant, that one only will exclude in our first step. So if you remember, while doing these testing of significance where we were calculating the ANOVA table, this would be my sources. One would be regression, one would be residuals, one would be total. Then we would have the DFs, we would have the sum of squares, we would have the mean squares, and we would have the F statistics. And this we would reject F if and only if observed would be greater than some F of 0.05 with appropriate degrees of freedom based on the regression and the error. Okay, this part I hope you remember. So whenever f observed will be greater than the f threshold, that is when we would reject h naught and we would say that this is significant. So in this case, wherever we will find these f's are less than the f threshold, those cases only we will consider that. So then you remember f greater than f threshold would be significant. Here we are looking for insignificant, which are not important to the model. So whichever f would be the lowest and would be less than that f threshold, that variable would be discarded. So keeping that in mind, we have to find out these two values as well. Now keep it here. So this, from the previous two exercises, we saw that f1 given 2, 3, 4, it came out to be something like 79.47, and f2 given 1, 3, 4, this was 22.536. Now I have to find out f3 given 1, 2, 4 and f4 given 1, 2, 3. So for this one, the same formula, SS residuals due to x1, x2, x4 minus SS full by MS full, and here again this one would be SS residuals due to x1, x2, x3 minus SS x1, x2, x4, this would be x4 minus SS full by MS full. So if we substitute x1, x2, x4 is this one. So here we have 0.289 minus 0.274 by 0.274 by 25. This would be something around 1.36, and this would be 326 minus 0.274 by 0.274 by 25. This would be 4.74. I'll just check the yes, this is 1.36, and this would be 0.326 minus 0.274 divided by 0.274 divided by 25. This is 4.74. Yeah. So so we have finally got four values: this one, this one, this one, and this one. Next, what we are supposed to find? We are supposed to find the degrees of freedom, because for each of these tests we are assessing significance with the df of the numerator was 1 and df of the denominator was 25, and at 0.05, because alpha we have been asked to take this. So this one is from the table. If you see here, for df25, 0.05 is 4.24, this value. So this threshold will be 4.24. Now you see each of these f's are greater than 4.24, which means that each of these variables are significant. Like I explained in the previous model, if you go from the ANOVA table, then f's greater than that f df numerator by f df denominator threshold, those are rejecting h naught, meaning significant. But this one, f3 given 1 to 4, this f is less than my cutoff or my threshold. So this x3 given x1, x2, x4 are already in the model is not significant. So that is why we will eliminate x3. Since f3 given 1 to 4 is less than f125 0.05. Okay, any confusion?
No, ma'am.
Okay, so then in the first step we are excluding x3. Now they are asking which one would be eliminated in the second step of this backward elimination process. So now we have eliminated x3. Then post elimination in this step, my full model will become y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 4 x4, because in the previous step we have eliminated beta 3, and there would be 3 restricted models. So my restricted models would be, in one case it would be beta 1 equal to 0, in the second case it would be beta 2 equal to 0, and in the third case it would be beta 4 equal to 0. So to test this we have to find out beta 1 given 2 4, beta 2 given 1 4, and beta 4 given 1 2. Okay, so again if we apply this formula, it would be SS residuals due to x2 and x4 minus SS residuals due to x1, x2 and x4 by MS residuals due to x1, x2 and x4. Now here what will be the error degrees of freedom? Here in this case error df would be
4, ma'am.
n minus 4.
N minus 4.
Yes, so it would be 26. So just putting the values, SS residuals 2 4 is this one, 1.312 minus 124, meaning this one, 0.289 by 0.289 by 26. Similarly here it would be 1 4, that means this one, 0.543 minus 0.289 by 0.289 by 26, and similarly in this case it would be 1 2, that means 0.328 minus 0.289 by 0.289 by 26. So if you calculate this one, this will be something around 92.03, this will be something around 22.85, and this would be something around 3.5. Now in this second step, my f threshold would be df of the numerator, df of the denominator, and the upper alpha 5% critical value. So this one we'll try to find out from the table, the f table. Here for 26, 0.05, it is 4.23. So this variable is 4.23. Now you see this one is greater than 4.23. This one is also greater than 4.23. But this one is not greater than 4.23. This is less. So we would, in the second step, we would eliminate x4 since f4 given 1, 2 is less than this one. Is it okay?
Yes, ma'am.
Okay. So next, what we have been asked to do, to find out the best regression model by backward elimination. So in the previous two steps, first step we excluded x3, second step we excluded x4. So now my full model will reduce to and the restricted model would be, there would be two. One would be beta 1 restricting beta 1 to 0, one would be beta 2 to 0. So here I am going to find out 1 given 2, f2 given 1. Same residuals due to x2 minus ss residuals due to x1 x2 by ms x1 x2, and here the degrees of freedom would be n minus
3.
3. Yes. So just by substituting 9.872 minus 0.328 by 0.328 by 27, and this would be x1, that is 0.556 minus 0.328 by 0.328 by 27. So if you compute, what are you getting? This would be something around 18.76, and this would be 9.872 minus 0.328 divided by 0.328 divided by 27 would be something close to 785.63. Now f127 0.05, this value is 4.21, this one. So this would be 4.21. Now you see this one is also greater than this one, and again this one is also greater than this one. That is, both of these variables are significant to the model. So we will not remove any of these, and the best regression model would be y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon. I have missed the epsilons everywhere. Okay, please don't make this mistake. This would be my best model. Okay.
Okay, ma'am.
So if you are given a backward elimination, then all you have to do is just fit all the models together and then test each of the parameters. Whichever is whichever is not significant, we remove that, and then again fit a reduced model, and then again test the remaining of the parameters. This is how you will land up at your best regression model via step backward elimination process. Now I'll have some on forward selection. So here again they are saying that which variable will be added at the first step of forward selection. So firstly we have nothing, we have to fit y equal to beta naught plus beta 1 x1 plus epsilon, or beta naught plus beta 2 x2 plus epsilon, or y equal to beta naught plus beta 3 x3 plus epsilon. Okay, so this points down to a simple linear regression problem. So if we just consider the ANOVA table, then this is my total, this is sum of squares, this is mean square, and this would be my F statistic. So when the total sum of squares would be equal to this one, when none of the variables are fit, there is no regressor in my model, so this is my total sum of squares. Okay, and there will be 1 degrees of freedom. So this is 11.067. Total degrees of freedom would be n minus 1, because summation yi minus y bar will always be 0. Okay, and this one is actually yi minus y bar whole square summation. So again, due to residuals, we would have n minus how many? 2, because there are two normal equations, and then due to additive property, regression df would be 1. So sum of squares due to residuals from the model is when I am fitting x1. So this would be 0.556. So then the sum of squares due to regression would be this would be 10.511. Okay, so the ms would be 10.511, and this one would reduce to 0.556 by, here we would have 28. Okay, and then this value would be 10.511 by 0.556 by 28. This would come to something around this would be something around 529.33. Would be 529.33. Write it clearly here. Similarly, here also we'll fit that ANOVA table, and then we'll find out the F value. Okay, so in this case, for the second one, this would be when I am including 2 in the model. Then regression residuals total, sum of squares df would be 1, 28, 29. This one is 11.067. This one is due to x2. So 9.872. So it would be 9.872, and this one would be just 1.195, and the F statistic would be 1.195 by 1 by 9.872 by 28. This is how much? This is something 3.389. And again, similarly, if we fit this one x3, then we would have these totals would change. So then SS due to regression would be 11.067 minus the value due to x3, that is this one 9.765 minus 9.765 by 9.765 by 28. So how much is it coming to? This is coming to something around 3.73, and due to x4 this would be, sorry, this is not sum of squares due to residuals, this is the f x3 when none is present. Okay, again f4 when none is present. This would be 11.067 minus 1.467 by 1.467 by 28. This one would be this will be 183.23, and due to x1 we had, so f1 when nothing was present was how much? 529, was 529.33. so then we'll look at these values. This is f2 when nothing is present, this one, this value, and this value. So out of these four, the largest is this one, largest f is f1 given when nothing is there, and we have to check is this greater than f1 28 0.05. okay, this value we have to check. So if we go to the tables directly, then this is 28, the value is 4.2. so this is essentially 4.2. so f1 is largest and it is also greater than 4.2. that means this f1 is significant. x2, x3, x4 are not significant in the model at this step. So the answer is, we'll first include the most significant one, that is x1. One thing is to note here, this is also significant, x4, but it is crossing this threshold value, the critical point, but we will include it stepwise, okay, in forward, not together. So the most significant one with the highest f which is crossing this threshold, will include that first, and after including this only we'll again fit models, and then only we'll include other variables. Okay, is it clear?
Yes, ma'am.
Okay, so then uh, the next thing is, what is the variable that will be added at the second step. So now we have already included x1 is already included in our model, so we already have this thing. Now we want to check what else we can add. So our remaining options are x2, x3 and x4. So then the next step is to calculate f2 given 1, f3 given 1, f4 given 1. Okay, so similarly SS residuals due to x1 minus SS residuals due to x1 x2 by MS residuals due to x1 and x2. So what will be the degrees of freedom for this one, x1 and x2?
N minus 2, ma'am.
N minus 3,
3. Okay.
because this finalized from last step. Now when we are testing these things, then the full model is becoming beta naught plus beta 1 x1 plus whatever we are testing, let's say beta 4 x4 here for this one, and the h naught is beta 4 equal to 0. Similarly for this one we are fitting, and our h naught here is beta 3 equal to 0. So in each of these cases the full model has 3 unknown parameters. So the MS residuals x1 and x2 would have beta naught, beta 1 corresponding to x1 and beta 2 corresponding to x2, right? So in each of the cases the degrees of freedom would be, if I write it again, residuals x1 minus SS residuals x1 x2 by SS residuals x1 x2 divided by n minus 3. Is this clear?
Yes, ma'am.
Okay, so just if we try and find out the values, f2 given 1, f3 given 1 and f4 given 1, we'll see that f2 given 1 would be something around 18.76, f3 given 1 would be something 1.48, and this one would be 0.646. And here our threshold will be f1 and 27 because n minus 3 for my full model. Okay, so this one if we check for 27 it is 4.21. So this one is greater, these are not significant. So we'll do what? We'll include x2 in our model. Okay, and similarly this is the last question for today. What is the best regression model obtained by forward selection? So again we'll do so in the second step what we have finalized, first step we included x1, in second step we included x2. So after second step our model is this one. but here we are yet to add x3 and x4. So in this case we have two criteria f12 and f4 given 1 2. So in each of the cases the full model here would be y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 without restriction. Here it would be beta naught plus beta 1 x1 plus beta 2 x2 plus beta 4 x4 plus epsilon. So the df's would be in each of the cases n minus 1 2 3 4. 26. We'll just compute these values from the table, and our cutoff would be based on f1 26 0.05. Okay, so this would come around 0.15 and this would come around 3.4 3.5. So and this one would be something 4 point if you remember 4.23. okay, so this is 4.23. Now none of these f's are crossing this threshold, so given 1 and 2 neither f3 nor f4 is significant, so we will not include them in the model, and the best model would be y equal to beta naught plus beta 1 x1 plus beta 2 x2. Is it clear?
Yes, ma'am.
Okay, so this is how we have run out of time. So this is how we will do it by forward and backward, forward selection and backward elimination. But if it were stepwise, then what we would do is after addition of after the first step only, the first one we are taking, okay, it will be same as forward selection. The first step we are taking this. After we have included, here we included x1, so after we have included x1, we'll just test this thing. We are just testing 3 given 1, 2 given 1, 3 given 1, 4 given 1, and then we are including these things also. Similarly, we'll also check the reverse, f1 given 4, f1 given 3, okay, after the second step. So by repeatedly doing this over and over again, we'll arrive at the best regression model from the stepwise regression. Okay, so I'll try to do another sum on stepwise in the next class, and if you have any doubts from today's session, you can post it in the discussion session. I'll try to answer it. Okay, but whatever I said, did you understand today?
Yes, ma'am.
Okay, okay. So thank you for joining. I'll see you next week.
Thank you, ma'am.
Thank you.